Hello everyone, thank you so much for being here. If you're here for the webinar on how to build a best-in-class data lake, you are in the right place. We are very excited to have you here. We have a very exciting presentation prepared for you today. Before we begin, there are a couple of items that I want to run by you, and those are the items that we are going to talk about today. We're going to cover what are the advantages of cloud data lakes, what are the challenges of building these data lakes, and in addition to that, we're going to walk through the best practices when it comes to implementing these data lakes on your infrastructure. Brock Griffey is also going to walk us through a live demo on how we can go ahead and apply these best practices in real life. And then at the end, we have a Q&A prepared for you. Without further ado, the time is yours, Brock.
Hi, everyone. So today we're going to talk a little about the advantages of the cloud data lake and how we can best implement those. So over time, we've seen that traditionally people have used many data marts, or they may have had an enterprise data warehouse to try and centralize their data. But it really didn't work. There really wasn't much data gravity around that. It's a complex process to get the data into one location. But what we've seen over time, and with the evolution of the data lake, we've seen that that's kind of become the centralized storage location for all of your data. We've seen this in year-over-year growth in S3 and other data lake environments, over 100% data growth. We've also seen 50% of the data will, from where we're heading now, 50% of the data will end up on the data lake by 2025. The advantages of this are the scalability, the ease of administration, the lower costs, and the durability and availability. So the data lake gives you the ability to separate your compute and storage, which makes it much easier to manage and maintain, much easier to scale, and much more durable because we can create replicas, and it's a lot cheaper because of this. So a little background on the data lake, if you may not have known it before, but the data lake kind of started off with Hadoop and the Hadoop infrastructure. The Hadoop infrastructure is a little bit more bulky, you could say. It had everything attached into one. It was all compute and storage rolled into one iron system. We had your clusters, and you had your file storage, which is Hadoop, HDFS, and then you had your jobs that run on top of it through Yarn or whatever scheduling system you'd have, like Spark, Hive, or maybe Dremio. This worked, but this meant that if you want to scale out, you had to buy more hardware, or you had to, if you need more storage, you did still, yet again, buy more hardware. There was no way to separate the compute and storage. So now, as we've seen the evolution of the data lake, is stuff like blob storage, such as S3 or ADLS, where it's completely separate from the compute. You can easily add files, easily add resources, and it keeps expanding the the cloud data lake environment. And then, because we can take the compute and have it separate, we can use things like Spark, Dremio, and Hive on top of the data lake in their own separate instances, running on Kubernetes, or if you're running on EC2 instances or Azure VMs, you can always do that. We can always spin up more resources that are separated out from the actual storage layer. So what we see when doing this is there are some major challenges when trying to build data on the cloud data lake. So we're going to look at a couple of those here. So some of the major challenges we see are higher latency and lower throughput versus local storage. So whenever you're using the storage locally, you don't have to worry about the latency of going across the data lake, across the internet to get to your infrastructure to actually read that data. Whenever you're another issue that you may see is controlling your costs and predicting your costs. So compute, in particular, you may not know how much it's going to cost you in compute. You may not know how to maintain and manage that with some of these offerings that are out there. They have the ability to elastically scale up, but they don't really have control mechanisms around that or ways to stop and prevent you from using too much and spending too much and predicting what you're spending. Then there's the other issue, which is the read requests costs. So we see that with ADLS and S3, you can get the data in there easily, you can land it easily, but the idea about pulling the data back out and reading that data, that's where you start incurring these costs. So we're going to talk a little about how we can reduce those 3 problems that you run into. And then, of course, the data governance and security aspect. While we can put security on top of the files, but how do we make more of a less rigid structure of the security and make it so we can dynamically put security on this and apply security to different aspects of data sets rather than entire file? So because of all those problems, what people see or what people end up doing is taking their on-prem solutions and putting them in the cloud. Or they may start using a cloud data warehouse, such as Snowflake or Redshift. And this just takes the same problem you've had on-prem all along and put it into the cloud, and you just moved it. It's a lift and shift. So what we see is you'll have your enterprise data warehouses that are typically heavy systems, expensive, proprietary data warehouses that you have to run in the cloud. Then you create this complex and brittle ETL process to move the data from your data lake storage into your actual data warehouse, where you can do the analytics on top of that. And then because performance is not always there in the data warehouse, you do the same thing you've done on-prem. You create cubes and extracts and aggregation tables in order to get that performance for your end user tools that are accessing the data there. And what this all ultimately leads to is higher cost of ownership and a decreased scope of flexibility, which is the exact opposite of what we want. And it's the reason why we propose a different way of doing this. So what is the right way to do this? So the modern data lake kind of is comprised of multiple pieces. One piece is, let's get the data into your account where you hold it and you are in control of it. And it's not some proprietary format, and it's not in a place that is not controlled by you. So that goes along perfectly with number 2, with the second spot here, where we are using open source formats. So you are going to be utilizing formats like Parquet and Orc and JSON, rather than using proprietary formats that are keeping you stuck with a proprietary system. And the whole idea behind all of this is that now, because you've used your account and your source formats, you can then use your own tools that you choose for best in class. So maybe you have the best in class compute that you want to bring with it, or you want to do some kind of specific tasks or analytics on that data. You might want to use your own tool. So maybe you're going to use EMR for ingestion and maybe use Spark for some kind of machine learning, but then you want to use Dremio for all of your querying. You can do that. Because we're utilizing all these open source formats, it allows you to pick the best in breed for each situation. So this slide here talks a little bit about that architecture. So again, we have our file system at the bottom with your Parquet or JSON text file types. Those are all open source, all easily readable, and all usable. Then we have your structure, your schema, your tables, and the different ways of doing that. So there's a variety of ways of doing that. You could easily use just Parquet files that have the schema built into it, but then you could also build your own additional schemas by using, file directories and the way the directories are structured, using a Hive metastore to give you structure on top of that, or glue. And there's also Delta Lake and Apache Iceberg. And we'll talk a little bit more about those in the next slide and some ways you can utilize those technologies to give you a data warehouse-like experience on the data lake. Then we have our compute, which is whatever tool you need for the job. So you're doing SQL querying, and if you're trying to do analytics and stuff like that, you might be using Dremio. If you're trying to do some kind of specific machine learning or something like that, you might be using Spark, etc. And of course, everything should be able to be used by any tool. So you have to have a variety of interfaces. So you should be able to use any of the libraries that are available from the client, and REST and ODBC, JDBC, and even Aeroflight, different ways of connecting to that data source and pulling the data out. And of course, most importantly, we have the security should be all the way up from the infrastructure from the ground up. And of course, and we also have our auxiliary services that you might be landing with data, so ETL ingestion type services and maybe some cataloging services on top of that as well. So everything should be able to interact and play together nicely. So you want to have this very open environment that you, again, can bring the best in breed and lower your costs, because now you've separated everything out and you're not stuck with one tool and only one tool. So I want to talk a little bit about some of our tables in the cloud and how can you do this? and how are things being done today? So tables in the cloud, the ideal way to use tables in the cloud are tables that have some kind of transactions for data and schema changes. They have a way to make it so you can increase your query planning and processing. Hidden partitioning helps out with that. It goes along with that. And then we have time travel, the ability to go back in time and look at data as it was in one specific point in time. So these different technologies already exist out there, and some of them are new and some of them are growing. So we're going to look at, just your typical files and directories. You have those already today. You have them on your laptop. You have them in your blob storage. They're already there. It's just files and directories. Any file format, Parquet, ORC, JSON, text. Those formats are all out there. It's not really been driven by anyone. It's just there, and they're not really transactional. It's just however the data is landed, that's how it's going to look. And then, of course, because of that, it is open source file formats that you're using. Then we have Hive. Hive is kind of community driven, so the community is kind of driving this. It's got a variety of formats that are readable by Hive, so Parquet, ORC, JSON, text files, but it doesn't really support transactions unless you're using ORC on HDFS, which kind of rules out using S3 and ADLS to get that transaction-like experience. And if you are trying to get that experience with performance, it makes it more difficult here. It is open source, that's great. Then we move on to AWS Glue. So obviously, Amazon is driving that. Now, that is a little limiting because now you're stuck in the Amazon's environment. So you're kind of getting stuck into one cloud data lake that you're going to be using. If you want to transition, you want to have a hybrid approach, that makes it very difficult for you to do that. For file formats, they do support a variety of file formats as well, but there's no real transactional type tables on that, and you don't really have open source capabilities in there. So it makes it harder for you to maybe submit code back or change something or do anything to help improve the product. Then we have Data Lake, Delta Lake with Databricks. Databricks, of course, is driving that. It's owned by them. It does support the Parquet file type, which is great, and it does support transactions. The one problem that you run into is that it's not truly open source, so it makes it very difficult for other vendors to go and build tools around the Delta Lake and get performance around that as well. So what we want to talk about last is Apache Iceberg. So Apache Iceberg has many contributors. It's open source, so many people are contributing to this. Netflix founded it, and they put that code out there. Apple's using it, Airbnb's using it, Adobe's using it, and they're committing code back. So they're driving this. So it's not something that's going to go stale. It's not something that is driven by only one company. It also supports a variety of formats, Parquet, ORC, and Avro. It is transactional. It does have time traveling capabilities, and it does allow you to have schema changes over time. So it has a lot of those benefits built into it, which will help drive you and the way you work with your data in the future. Another thing we want to talk about is how you're doing processing. So a lot of the data that you're working with is going to be using some kind of processing engine. And you'll notice that one of the industry standards that's out there is Apache Arrow. And Apache Arrow is a way to read data in memory. And this also has one of the things that Dremio actually, our co-founders created, and it was created by Dremio itself, and we put it out there in the market. And it's open source Apache project, so many technologies have adopted this. So we have Spark has adopted it, Python's adopted it. All these different data science tools adopted it. We have it in Java, C, C++. So many programming languages can use the libraries to get the best performance. So you're not stuck using a proprietary data format. You're using an open source format that can be utilized anywhere. So this helps adopt all these new technologies into the market to be able to utilize the same formats you're using with the tools that you have at hand. And you can see that this is growing rapidly, 10 million downloads a month. This is growing very, very fast. So what does it look like when you actually implement it? I'm going to talk a little bit about how we do this here at Dremio and what we expect to have happen in the future. So enabling a open architecture for data analytics, what we have done is we are decoupling all of the different components and allowing you to bring the best in breed of whatever is out there. You use your own account. So you're not stuck using someone else's account. Your data is not stuck in someone's account. It's in your account. So you can use your on-prem, you can use your cloud storage as well. So you can use AWS, Microsoft Azure, different services you want, and you pick your own storage layer. And because we're doing that, we're allowing you to pick your own data formats. So however you need to read and write your data formats into the data lake, that's how you can do it. We would typically stick with open source formats, such as CSV, Parquet, Orc or Hive, JSON. And then we have the ability to pick whatever data engine you need. So you have your best in breed engine. So maybe you need to do some machine learning, so you use Spark. Maybe you do some data ingestion, so using EMR. And then, of course, anytime you're doing queries and processing, we would utilize Dremio. And by utilizing Dremio, there are a couple things in here that are going to help reduce your costs because Dremio is very resource efficient. It's powered by Apache Arrow. So when we read things like Parquet, which is compressed and columnar data, we're able to read only the data you need, not the entire data. So if you read a CSV file, you have to read the whole CSV file to get the data out. So it's going to cost you more to do that. Whereas if you're using a Parquet file with Apache Arrow, it only reads the columns it needs to read. So you're reducing the amount of data being pulled through. So say maybe you have a 1 terabyte file. Instead of reading the whole 1 terabyte, you only need to read 1 column or 2 columns. You might read a couple hundred megabytes. So it makes the total cost of ownership much lower. So again, these are some of the ways we have actually helped made things more efficient within Dremio. I talked about a little bit about the Parquet and Arrow already. So I'll go ahead and go to the next one, which is data reflections. So data reflections is almost like a hybrid between a materialization and a index across your data. And this is, again, all this information is managed and maintained by Dremio. Your end users don't need to do anything. Your data scientists and your DBAs really don't do anything besides check mark a box and turn it on, and it will automatically get used by any query coming through against a data set. And I'll show that in the demo as well. And so this helps, again, reduce the amount of work being done. You kind of do all your work up front and reuse that work rather than trying to go against the data every single time and do processing every single time. It's already done for you. So you have a shortcut to the data. It also reduces the cost of reading all that data over and over again. Then we have our columnar cloud cache, which is the ability to cache parts of your data onto the local hardware that you already have provisioned. So if you have provisioned hardware that has NVMe storage, you don't have to worry about the latency from the data lake. So we're solving that latency issue that you had before. And then, of course, because of a massive parallel reader, we're going to even further reduce the latency issues and the data read issues they may see with other solutions out there. Another thing we have the capability of doing is what we call elastic engines. So elastic engines give you the capability of separating your workloads and giving you workload isolation. So we can take a workload and create what we call an engine for that workload through our workload management. And when a query comes in, it'll get evaluated with a rule. And whenever that rule gets applied to that query, it will go and push it to a specific workload. In those workloads, we can specify the engine it belongs to and the different resources that it's allowed to use, like how much CPU and how much time it can use. This enables it to, for a engine, whenever the workload comes through, or when the workload comes through, it will turn on and off these elastic engines, these EC2 instances that are running, and give you the ability to not run something 24/7, but only run it when you need it. So you're reducing your EC2 compute costs. So today, this is available on our AWS version of Dremio, and in the future, it'll come to other products that we have as well. But this is a great way to make sure that you are doing resource isolation. You're able to get a better idea of how much resource is being used. You don't have idle compute costs, and it allows you to scale out as you need as well. The last thing I want to talk about is a little about the security aspect, right? So we mentioned security is important. So by using our self-service semantic layer, we can apply a way that end users can interact with their data sets while still providing your security on top of it. So of course, when you have your data land in the data lake, you can use CAN-mass encryption and other types of encryption on your data lake. And then Dremio can read that data directly out by using that encryption as well with no issues. And then once you have read it out into what we call the raw zone, it's almost like registering the data set and making it available. Without copying or doing anything with the data, we can just read it directly, and we can expose that out to your end users through our semantic zone, what we call virtual data sets. Think of it as a view. And in those virtual data sets, we can provision who has access to those virtual data sets. So we can do provisioning at different levels. We can do it at spaces. We can do it at folder level. We can do it on the virtual data set. And we can even go down into the column and record level. So there's different ways of doing all of that security built into Dremio. It reduces the complexities around security and helps make it easier for you to share out these data sets and give you better data set discovery. And of course, all of this has, your interfaces through ODBC, JDBC, REST, and Aeroflight, which gives you any of the tools they're used to using today, they can still use. So just going back to what we touched base for on the beginning of this was about your higher latency and lower throughput versus local storage. So you have all these challenges, and this is solved by Columnar Cloud Cache. This helps solve that, as well as controlling predicting cost because of compute. We're using elastic engines. Our resource efficient compute through Arrow and our reflections are all going to contribute to lower compute cost and helping you control those compute costs. We can turn on and off the instances. We can make sure that we're using things more efficiently. For your read requests, we can reduce those costs of your read requests. I mean, it could cost you on average up to $400,000 a year to just read data out. So we want to make sure we do that as efficiently as possible. So Columnar Cloud Cache is going to help you with that by reducing the number of reads from the same data set over and over again. We'll have that stored locally for you. And then reflections, again, will do all the work up front for you, so you don't have to worry about rereading large data sets just to get a small result set back. And then, of course, Arrow and Parquet file types are going to help reduce that as well. And then back to the data governance and security, your semantic layers will help provide that security for you. All right, now I'm going to go ahead and talk about how, I'm going to show you actually how we do this in real life. So I'm going to pull into a demo, and here's the scenario for it. So the scenario that we're going to work through first is a trend analysis on taxi ride data for New York City taxi data. This data is going to be living in our Azure data lake, and we're not going to copy or move it anywhere. We just want to read it directly from the data lake. So someone has already landed it there, and we're just going to read it without any copies or extracts or anything. And then we want to be able to quickly validate that data set and maybe do some exploratory analytics on Tableau. And it's one thing to mention here is Tableau is not going to be doing any of the processing. It's actually going to write the queries, and Dremio is going to do all the processing. And Dremio will return back the result sets to us. So as we go through that, I'll make sure that you guys can see that. And just to give you a little more information on the environment, it is 3 executors with 8 cores of CPU and 32 gigs of RAM. We'll be using Tableau for that first demo. And for the second demo, I'll be using Jupyter Notebooks. And for the first demo, we'll be looking at Azure Data Lake storage only. And then in the second one, we're going to take that Azure Data Lake storage and we're going to do a join to a Postgres database so you can do a little bit more analysis for our second scenario, which will be doing some machine learning on taxi ride data set. What we're going to do is we're not actually doing machine learning, but we're going to take that data and we're going to expose it out to a tool like Jupyter Notebooks, where a data scientist could then do machine learning on top of it. All right, so I'm going to go ahead and get into the demo here. Just give me 1 second to switch my screens. We're going to go ahead here and we're going to look at Dremio's web interface. So when you first log into Dremio, this is exactly what you'll see for your web interface. We have our own data sets already registered over here, so we have some of these sources registered. And right now what you see is my own space that I have access to. So if I wanted to come in here and I'm going to start with the first scenario of looking for a data set, I'm going to just go ahead and type in taxi to find that data set. So we can easily search. I did find this data set here. I'm going to go ahead and click on it. So you can see in here, Dremio is fully ANSI9 SQL compliant, so we can write a SQL query directly against this data set if we want to. For now, I'm going to not write anything against that data set. I just want to look at this data. So we can see we got some information here. We got some pickup dates and times, drop-off dates and times. We have some other additional information about how long a trip was and just other information about this trip. So this gives you a really good way to just look at the data and explore it without having to write a query against the whole data set. We just get a quick preview of that. This catalog view just gives you a really good way of just manually entering in and sharing information with other users on what this data set is. And we've already done that here. So we just put a little graph in there, or a little text in there, and some photos in there as well. And one of the things I want to point out is this is 1 billion records in ADLS. And we're going to read that billion records on ADLS. We're not going to move it anywhere else. It's just be directly out of ADLS. So now that I'm back here on this main page, I'm going to go ahead and pull this data set out into a Tableau interface. So all I have to do is click here, and we'll see that we have several options. And I'm going to click this Tableau button. Now you can use anything with ODBC or JDBC like I mentioned before, or REST API or Aeroflight. But this is just a quick link, and it just downloads a TDS file, which is just a connection to Dremio in Tableau. It's not any data. So I'm going to go ahead and just open this up. And let me switch over the screen that's sharing. So I'm just logging in using my LDAP credentials. And once I'm in here, you'll see this is very typical of most BI tools. It's pretty standardized at this point. So in here, I have my measures on the side and my dimensions on the side as well. If I wanted to start doing some analytics on this, I could easily come over here and pull over the number of records. Let's just get a count of how many we have. So we can see that's over 1 billion records that I just did a summation on. Dremio did all the processing. Tableau just passed the query to Dremio. So maybe if I want to do some more analytics on this, I could easily go in here and grab something like the pickup date time, drag and drop it. So now we have this nice little graph. But what I would really want to do is I'm going to just change this so we can get a better view of this. And we can see a better breakdown now of how that is. So right now, we have read the data directly out of the data lake. And if you want to dig into deeper granularity, typically with a data warehouse or any other tool out there, to get performance, you're going to have a cube or extract. It's 1 billion records. Slicing and dicing that data is not easy. And if we want to drill down, let's say we want to go down to the year, month, or even the day level, it's going to be slow. And most of the time when you start making clicks in here as an end user, you're going to be making a click, go get a coffee. Make a click, maybe I need to use the restroom. And then by the time you get back, you're hoping that it's done doing the processing. So in Dremio, because Dremio is doing, or in Tableau, because Dremio is doing all the processing for us, or any other BI tool you're going to be using, we can easily click, I'm going to do year, quarter, and it comes back instantly. So at the speed of thought, we're able to give that lightning fast query and response back to you. You can easily see that it's been drilled down by year, quarter, or let's go down to the year, month, or maybe we want to go down to the day level. So it comes back instantly. And every time, Tableau just submits that query back to Dremio, and Dremio pulls back those results, and then Tableau visualizes it. So you want to know how we do this probably. So let's go back to our Dremio interface. And now in here, we're going to go to the Jobs tab. This Jobs tab shows every query that I've ran. And so I can see in here from the very beginning that we did a sum on all of the queries of all the records to give us back the number of records we had. And if I come back through here, I can see each query that was ran. And you can see, it gets more and more complex as time goes on. And you can see all those queries created more complexity, but Dremio had no problem breaking it down and giving us back those results. Every one of those queries came back in less than 1 second. So how are we doing this? So one of our core technologies that I mentioned before is our reflections. And our reflections here, an aggregate reflection is actually being utilized. And this aggregate reflection is giving us these different dimensions and measures that we can select. We click save, and Dremio will automatically keep that up to date and refresh it for you without the end user knowing that it's there, without any additional maintenance around this. And it will store it out in your data lake in very small amounts of data. So you can see that this is just like an index across your data. It's only about 16 megabytes. It's not big. And it manages it for you. As an end user coming in and running a query, you always write your query against the same data set. You don't need to know this exists. You just know that your data is coming back very fast and very efficiently. All right, so now that we've finished the first scenario, I'm going to go back and we're going to go to the second scenario. So just a brief recap, the second scenario is going to be me joining a taxi ride data set, the same one we looked at before, to a weather analysis in Postgres. And then I'm going to pull that data over and put it into Jupyter Notebooks and do some brief analysis on top of that as well. So let's go ahead and get started. Just search for taxi again. I'm going to pull up a taxi data set. Now that we're in here with this taxi data set, if I want to join this, I can just go ahead and click join. We'll see that this join has been done in the past and that I have this option to just click on this. So I'm going to go ahead and look at this real quick. And we can scroll over and we'll see that this is where the join's happening. And we can see that we're getting records back. So we can see the actual weather here now. So I'm going to go ahead and apply that. Now this data set's here. I'm going to go ahead and save this. Save as. And put it as Brock weather. I'm going to save my own space. And now it's saved my own space. If I wanted to save that out with other users, I could easily save it into another space, and other people would be able to see that. I could easily put it into a secure secure folder where only specific users could see that as well. And just give you an idea, now that I've saved this, I have the option to look at the graph, so I can see the data lineage, and I can see where this data came to and from. So if I come over here to Jupyter Notebooks now, I can easily connect to Dremio, and we can get some data out. So I'm going to do this right now and just kind of give you an explanation of what's going on here. As a data scientist, they'll come in and they will set up something like an ODBC connection. So that's all this is doing. This is setting up our ODBC connection. I'm just pointing to the Dremio server, and I'm just putting in my username. When I click run, it's now going to prompt me for my password. So I'm going to log in here. Oh, I put in the wrong password. So let me try that again. Okay, so now we're connected. And if I come back over here and I go back to this data set, I can click this button here. This copies. You see it says copied at the top. This copies the actual data set here. So I'm going to replace this just to show you that we're using this new data set. And now I'm using that there. I'm going to go ahead and run. It came back with the results instantly. So this SQL that we used this data set that we just built. We're extracting the month from the pickup date time, and we're going to get the temperature back. And we're going to limit the number of records coming back. Dremio is going to process all of that, but we want to make sure that we limit the number of records coming back. But this gives you a really good idea of what the data looks like. So if I want to come down now, and we're going to run that same query, but we're going to now look at a little bit of analysis on this. We're going to get the temperature max, and we're going to look at the average distance, and maybe try and get an idea of, does the temperature affect the length of a trip? So I'm going to go ahead and just click run, and you can see this graph pulls up. So it just processed all that. The graph's just coming back through a Python plotly. So we're pulling that back from the plotly. And now we can do some additional analysis. So the idea behind this is that no matter what tool you're using, Dremio can be your processing engine. And that engine then runs the data lake, can read the data directly out of the data lake without any additional steps, without any additional ETL work going on, or complex processes to manage and maintain. We can easily and quickly read the data directly from the data lake and be the engine. So that's all I have for this piece. I'm going to go ahead and hand it back over to Lucio for the final part of the presentation.
Thank you so much, Brock. Before we go, there are some resources that I want to point the audience to. If you want to learn, and hope you do, more about Dremio, please go and visit our tutorials and resources. We have a ton of tutorials in there. We have a lot of information on how to work with Dremio and your favorite BI or data science tools, as well as how to work with your data sets and do everything that Brock was showing us throughout the demo. Also, we want to invite you to try Dremio University. It's an online learning platform that we have made available to you for free, where you can go ahead and take the courses, and in addition to that, you can launch your own virtual lab with Dremio Enterprise Edition in it, so you can follow along the exercises that we have in each one of the courses. And once you're done learning and experimenting, please go ahead and join the Dremio community, where we have a lot of information in there as well. You have there the opportunity to ask every single question that you may have in regards to Dremio. Other than that, I want to thank Brock and I want to thank all the audience for being here with us today. I hope everyone is staying safe and healthy, and we will see you later. Bye-bye.